Okay, good morning to all. So today we are going to learn one very important thing which is called external hardware interrupt. Using this, basically we will be learning the this is very much needed for pulse counting. So we will be learning today slightly about the quadrature pulse counting also. What is quadrature pulse and how it is to be counted. Okay, so already I think I have explained about interrupt. What is interrupt? Basic concept with some example. Have you understood what is interrupt? Or do you know what is interrupt?
Yes, sir.
Okay.
Yes, sir.
I think during that ADC I have explained using some example. So interrupt means microcontroller will be never in halt. Like if you put delay also one kind of interrupt, but it will if you apply the command of delay, so the entire program, entire microcontroller activity will be stopped till that time. But interrupt is such an interesting command in microcontroller that, or event, not command, event in the microcontroller, that if that interrupt happened, then it will be redirected to that particular service routine and it will be executed. So now first we will go to the code. So these are the things already you know. These are the things already you know. I have defined one variable called x. Here I have used one user defined function, external interrupt initialization.
Sir, sorry to interrupt, but your screen is not visible.
Oh, achha, okay. I have not shared. এবার দেখতে পাচ্ছিস? Is it visible now?
Yes, sir.
So this is the area for header file inclusion, and here I have defined one variable called x. And now you see I have used one function called extint initialization. So that I have defined here. I have used few 2-3 registers. So already that status register, you know, already I have explained that if any kind of interrupt to be enabled, then the ith bit of the or the 7th bit of that status register should be enabled. So that's why I have used here. And now here I have used 2 more register, that EICRA and EIMSK. So let us see what is those. So first I will go to EICRA. You see, this is the external interrupt control register A. Okay, but here I am just going, I will show you the interrupt, because this particular IC having two interrupt 1 and interrupt 2. That means here it is designated as interrupt 0 and interrupt 1. If you see my drawing here, you see that push button, it is connected to that PD2, which here it is written INT0, that means interrupt 0. You can see also in the pinout, you see this is the PD0, PD2, which is as INT0. Okay. So what is this 2 bit? If you see my code here, you see the last 2 bit means the last 2 image LSB is enabled. Why I made this? These 2 bits, what are the things? You see, this is called interrupt sense control. Means, so this first 2 bits will be for interrupt 0 and second 2 bits it will be for interrupt 1. So I have used interrupt 0, so that's why I have only configured interrupt 0. You see, the sense, what kind of interrupt it will respond, whether it is low or high or raising edge or falling edge. So for this particular, I have used the raising edge interrupt. So if it is raising edge, that means if the pulse is going from, the transition is taking from 0 to 1, that is called raising edge, and if it is detected, then the interrupt will occur. So for that purpose only I have used 1 1. Okay, so you see, that's why I have used here. And here I have used another register, interrupt mask register, EIMSK. So let us see what is this. You see, interrupt mask register, external interrupt mask register, the first, the LSB is for 0th, 0, interrupt 0, so I am using interrupt 0, so that's why. So if I want to enable external interrupt 0, if I want to use, then that particular INT 0 bit is to be made high. So for that only I have made it. Okay, now that means if in that particular pin, that PD2 or INT0 pin, any raising edge is coming, it will redirect it to this service routine, and in that service routine I am just incrementing the counter. One variable I have defined X, which is to be incremented. Okay, this only I have done. So let us see how it's work. A student of Kharagpur and Jadavpur, they are available or not? If any student of Kharagpur, Jadavpur, sorry, Kanpur, they are available, just respond.
Yes, sir. Yes, sir.
Shayok?
Yes, sir.
Yes, sir.
My computer is slow, so many things recording, all these things it compiled over. Now you see, if I press the button, you see it is press, I am holding, nothing is happening. Only when it is triggering from 0 to 1, it is only increasing. Now I release, nothing change. But again when I press, at that instant, you see I press and hold, nothing happened. Only one increment. So that means when it is raising edge is coming, only this interrupt occurring. You see? But if you change the interrupt sense control to falling edge, so when you are pressing, that time the counter will not get incremented. When it will going from on to off, that time only it will be incremented. You can do that, and you can try it by your own, and you can do it. Okay, I'll send the code, and you can change for all other sense. You see, only when I am pressing, only that time only, during the transition only, it is interrupt is acting. So what I will request
Sir,
Sir, is the clock activated only when the button is pressed?
Button is pressed and the transition is taking place. Not button is pressed when the transition is taking place from 0 to 1. When this is happening, at that instant only the interrupt is enabled, because in the interrupt sense sense control bits we said that raising edge only the interrupt should happen.
Sir, where is the clock signal in the circuit?
It's not clock signal. I have given on 5 volt, and it is given to the interrupt 0 through a push button. When you are pushing, normally that pin is, you see now the pin is grounded. If you see, that particular pin is grounded through the resistor R1. So now it is in 0 state. When you are pressing this push button, then that 5 volt it will be coming through this, and entire 5 volt will appear across the interrupt pin. So that time only the transition will taking place from 0 will take place from 0 to 1, and that time only the
5 volt is acting as a clock.
Yeah, like clock. You can apply clock. You can instead of this voltage, you can apply clock also. It is automatically increasing. That I will show you during the quadrature pulse counting.
Okay, sir.
Okay, sir.
Anybody else? Any doubt? Okay, I am closing it then, because it is computer is getting slow, so I have to draw something. No doubt, correct?
Yes, sir.
Yes, sir.
Now we will learn slightly today what is quadrature pulse. That's all. That is the last topic today. Say this is one square pulse. Okay, this is a square pulse, and you know this is the period. Okay, so this is total 360 degree, so this is my 90 degree. So quadrature means 1/4, that means 90 degree. So if the two pulses, if the two pulses they are aparted by 90 degree, it is called quadrature pulse. And this quadrature pulse is very important for pulse counting, like our speedometer, our car speedometer, everything. So let us take, this is my A, pulse A, and pulse B. I will explain later how the pulse is generated. It is very simple. It's a very electromechanical system, it's a very simple thing. So the device which will generate this pulse from rotation, it's called encoder. Okay, so here you see first the pulse A, it is 1 and 0. So this area it is 1 0. Okay, so let us split. And this area it is 1 1. This area it is 0 1. This area it is 0 0. This area it is 1 0. And this area is 1 1. And this sequence it will repeat. Now we learned how to count the raising edge, because this is one raising edge, this is also raising edge, this is also raising edge, this is also raising edge. We already learned in microcontroller how to count the raising edge pulses. We already learned it. So let us make some truth table. So this is my present state and this is my past state, and this is 0 0, this is 0 1, this is 1 1, this is 1 0, this is 0 0, this is 0 1, this is 1 1, this is 1 0. So now if the wheel, say this encoder is connected with a wheel, if the wheel is rotating in forward direction, then it will happen like this. If it is a reverse direction, it will have, sorry, if it is forward, then it will move like this. If it is reverse, it will move like this. The pulses will generate in this fashion. Okay, now say, so if my, so for a certain instant, this is my past state and this is my present state. So if my past state is 1 0 and present state is 1 1, then I will consider it is rotating in forward direction. Okay, if my past state is 1 0 and present state is 1 1, then it is rotating in forward direction. I will increment the counter, whatever the x. If this state is detected, then I will increment the counter. That means 1 0 to 1 0 to 1 1. So here I have to increment the counter. Okay, so if my past state is 1 1 and present state is 0 1, then also it will be incremented. So 1 1 to 0 1, it is incremented. If my state is 0 1 to 0 0, you see it is 0 1 to 0 0, then also I have to be incremented. If it is 0 0 to 0 1, 0 0 to 1 0, then also it is to be incremented. Now decrement means ulta. First this state will occur, then this state. So if past state is 1 1 and present state is 1 0, then it is to be decremented. Past state is 1 1 and present state is 1 0, it is to be decremented. Similarly, if the past state is 1 0 and present state is 0 0, then also it is to be decremented. If the past state is 0 0 and the present state is 0 1, then also it is to be decremented. If my past state is 1 1, that is over. So if my past state is 0 1, 0 1 to 1 1. If my past state is 0 1 and present state is 1 1, then also it is to be decremented. So this is my entire all the possible state in this pulse. It is over. These are the don't care.
Sir, here what is the variable that is incremented or decremented?
I will define one variable like x in the code, whatever I have defined. This it will count the number of pulses. So if I know the pulse per revolution, that is called PPR. If I know the pulse per revolution, then I can find out how many pulse I can receive. Say pulse per revolution is n. So after a t time elapsed, I have counted a pulse is nc. Then the number of rotation happened is nc by n, and which is happened by t time. So divided by t. Divided by t. T, if it is in second, into 60, it is called RPM, rotation per minute. And if you know the diameter of the wheel, you multiply pi d with that into RPM. So this much meter or centimeter per minute, that is your speed. This is the technique. So when we will be starting the motor control course, means in this course I am not going to give you in details of the induction motor control, but it's very important today. I'll give you a flavor. Then in the next year or next semester, when you will be doing the again course, that time you will be doing in details of motor control. In motor control, basically we have to learn DC motor control, normal DC motor control, separately, that means separately excited DC machine motor control, then servo motor control, stepper motor control, induction motor control, all these things. If you done this, then the entire any kind of motor you will be able to handle in the industry. So hope this, what is quadrature pulse? This is called quadrature pulse counting, QPC. So hope you have understood what is quadrature pulse counting, correct? Anybody having any doubt?
Sir, when we are going in forward direction, then it is counting up, and then we are like going in backward direction, it is counting down.
Yes. When it is going forward direction, we will increment the counter. When it will be going the backward direction, we will decrement the counter.
Sir, here, what is actually going in forward or backward direction, like the B wave. That is what we are like seeing.
You see here, if you see that why it is quadrature 90 degree apartate means, if it is going forward direction, you see the first raising edge it will occur for A pulse, and after that only raising edge occurring for B pulse. But if it is going for reverse direction, then the first raising edge is occurring for B pulse and then only coming for A pulse. So these are the state change. These are the state change happening. I think you will be learning state machines. You have learned in digital electronics.
Yes, sir.
Yes, sir.
That Moore machine, Milli machine. So those are the things. Also can be earlier. It was like that only, but today microcontroller is there. It is a matter of simple coding.
Sir, so basically like implementing the variable based on the relative movement of A and B.
Yeah.
Incrementing.
That device is hardware is connected with the rotating wheel of the car or machine, whatever name. Got it?
Okay, sir.
Okay, sir.
Anybody else having any doubt? Okay, so hope I am stopping the recording because it is getting recorded.